Hi, this is a tutorial on how to solve volume temperature problems. A 12-liter balloon was cooled until it reached 100 Kelvin and a volume of 3 liters. What was the original temperature of the balloon? So right away, I'm going to go ahead and fill in the initial original temperature of the balloon with an X. And then all the other numbers. So it says the 12-liter balloon was cooled. So initially the balloon was at 12 liters and we cooled it until we got to 100 Kelvin and volume of 3 liters. Okay, since this is a volume temperature relationship, this is direct relationship, meaning as one variable increases, the other one will do the same thing and vice versa. So right away I know that volume went down, and since it is a direct relationship, I'm expecting the temperature to go down as well. So that means that your X is actually going to be bigger than 100 Kelvin because the initial volume was bigger than the final volume. So right now we're going to go ahead and set up our problem using for every statements. We know that for every 12 liters, there is, there is X, okay, and then for every 3 liters, there is 100 Kelvin. Okay, so those are my two for every statements. I need to figure out the ratios next. So I need to figure out how we got from 12 to 3. Well, you know you're going from a bigger number to a smaller number, so you're going to be dividing, okay? And in this case, we're dividing by 4. So since, again, it's direct relationship, both variables are doing the same thing, we are going to be dividing x by our 4 as well, same exact ratio. It's hard to do math that way, so what we're going to do is go backwards. So we're going to go 100 times 4 to get to x, and that will give us our x to be equal to 400 Kelvin. Take a look at it, make sure that it makes sense. Did we expect our x to be bigger than 100? Absolutely, and it is. It's 4 times bigger than the final temperature, just like the initial volume was 4 times bigger than the final volume. Now for the particle picture. The two variables that are changing are volume and temperature. So that means pressure staying the same, so the same number of smashies, and number of particles is staying the same. So as you can remember, we are doing particle pictures in a specific order. So that means that we're going to be doing volume first. Okay, we need to address volume first. Then we're going to address the number of particles, then temperature, and then pressure. Okay, so volume is the size of the box. The initial one was bigger than the final one. Okay, and now we're going to go ahead and fill it in with the number of particles. I'll keep it simple. I'll keep it at 3. Okay, the next thing I'm going to do is the temperature. That's number of whooshies. The initial temperature was higher than the final one, so I'll make the initial particles have 2 whooshies, and then my final ones have only 1 whooshie. And then the last thing we need to address is the pressure. The pressure stayed the same, so that means we're going to have 1 particle bouncing off in this picture and 1 particle bouncing off in the final picture. This is it. Thank you.